This video is here to hopefully help you with your learning targets of combining like terms and using the distributive property. And we're going to start with the first learning target there, which is combining like terms. So we need to figure out what an actual term is. And so in your notes, if you want to write down that a term is an expression basically separated by pluses or minuses. That's kind of a general definition. So probably a good way to describe it is to take a look at an actual example itself. As I said before, it's being plus or minus, and so we're not talking about multiplication at all. So we have a 7 times x. As you can see, I've color coded them. We have a 7x is my term, my first term here, plus 5. 5 would be my next term. Minus 3y would be my next term, plus 2x. Each one of these is separated by a plus or minus symbol. Like terms, I would write down in my notes, can be grouped together. So we can combine them together because they have the same variable and are raised to the same power. So when I say raised to the same power, what that means is each variable has a different exponent. If we take a look back at our example here, x, even though it doesn't look like it, is actually being taken to the first power. 5 doesn't have a variable, so we're not going to worry about that power. Y is taken to the first power, and 2x is being taken to the first power as well. So looking across, obviously I've color-coded these terms that are here, but you can hopefully tell that 7x and 2x are like terms because they have the same variable and they are raised to the same power. And so what I can do is I can simplify this expression by combining our like terms. And so what I'm going to do is whenever I am combining like terms, I use different shapes to kind of group the like terms together. And so what I do is I typically start off with a circle of 7x, and I scan across the rest of the expression. I say, where else do I have an x? And I have it at positive 2. And so what I'm going to do is I'm going to circle it, and I'm going to make sure that I circle the symbol out in front of it. How I like to think about combining like terms is I like to give names for the variables themselves. So here's an x, so I'm going to call this a xylophone. And so I have 7 xylophones, and I'm going to add 2 xylophones to it, which hopefully you'd be able to say, well, 7 xylophones plus 2 xylophones is equal to 9 xylophones. And so that x just stays a singular because it's not going to change to an x squared or anything. We're just adding. The only thing that changes is what's the number out in front, which is called a coefficient. Then I scan across, and as you'll learn later on in your mathematical career, you typically go for the variables first. So I'm going to look for the next grouping of terms that has a variable with it, and I'm going to use a different symbol to represent that like term there. We have a negative 3y. Notice how I squared the outside of it with the symbol with it. There are no other y's there, so it is just a minus 3y. And then last but not least, I will put a triangle around my positive 5. So I'm going to do a plus 5 there. There are no other like terms to be able to combine, so really this is my final answer. I can't combine the other ones, they're not like terms. Let's do a couple practice here. We're going to combine like terms. And so what I want you to do is I want you to scan across and see if you can find the variables with it. So if I take a look at A and I start with let's look at my 7y there, and I scan across and I look for other y's that are there. Hopefully you are writing this down and being able to circle the negative 3y and the positive y, the plus y there. Realize on this last one here that there's no number that's out in front of it, but one of my favorite phrases, as you know, is you can always squeeze in a 1. How many y's are here if there's no number out in front? That means there is one y, so I'll make that a gigantic 1 there. So I have 7y minus 3y plus 1y. So 7, if I use my names for them, 7 yo-yos, take away 3 yo-yos, and then add one more yo-yo to it. That would give 5 yo-yos. Then, now that I've exhausted all the y's, then I would look for the next like terms, which looks like we have a plus 8 that's there. I would scan across and look for my other like terms there, which would be the plus 1. So positive 8 minus 1 would give me a plus 7. That would be my final answer. What I want you to do right now with using that kind of idea is I want you to go to B and I want you to try to do that problem on your own. So if you could pause the video at this point and try it and then come on back and see if you can get the correct answer. So hopefully you were successful with this one. Let's take a look. We have a 9x that I'm going to circle. I'm going to scan across and find my other x's that are there. So I have a negative 2x. 9 xylophones minus 2 xylophones is equal to 7 xylophones. Again, notice how I'm only combining the, or only changing the coefficients, the number out in front, not the variable itself. That stays the same. Then I scan across and look for my other like things. The previous question, remember I said I tried to do my variables first, so I'm looking for my plus 3y's. There's no other y's out there, so I'm just going to put the plus 3y alongside the 7x. And then last but not least, I have a plus 5. And so final answer would be 7x plus 3y plus 5. That's the first part. Now we're going to move on to the second learning target, which is all about the distributive property. So in your notes, if you could write down distributive property, and the key piece of it is this part right here, where A, notice how there's no operation in between the A and the parentheses, which means that that operation is actually a multiplication. So A times what's called the quantity, B plus C, is equal to A times B plus A times C. And one way I show that is by drawing arrows. So A times B, that arrow means multiplication, plus A times C. And so you'll see me do that. And what I call these types of problems is swoop swoop problems. It's the act of actually drawing the arrow is a swoop to me. These types of problems are called swoop swoops or about distributive properties. So for example, in this swoop swoop problem, we have 2 times the quantity, 3 plus 5. I could follow PEMDAS and I could do 3 plus 5, which is 8, and then multiply by 2 to get 16. I'll put that little note off to the side there. Or I could use the distributive property and say 2 times 3, my little swoop there, and swoop the 2, and do 2 times 5. Well, that would give me 2 times 3, which is 6, plus 2 times 5, which is 10, which if I added those together would give me 16. And the answer is exactly the same. So no matter which way you want to do it, you'll still get the same answer. Now you may ask, well, couldn't I just use PEMDAS? Well, in certain situations, yeah, you can. But if I go to the next slide here, which is we're going to start with the one on the left side there, has a variable with it which makes things a little bit more difficult. All right, so let's try the left one together. If you could copy that down for me. If I take a look, I have a quantity, I have parentheses, negative A plus 2, and then there's no operation, so as we know, that's multiplying by 4. What property allows me to basically flip things around? Because typically you see the number out in front of the parentheses. Hopefully you're saying to yourself, that's the commutative property, which tells me that basically I could multiply in any order. And so what I'm going to do to make this a little bit easier is I'm going to move that 4 out in front, then do a minus A plus 2. Doing this distributive problem, or the swoop swoop problem, what we're going to do is we have 4 times the quantity, so we're going to draw our swoop and multiply them together. 4 times a negative A. 4 times a negative A. That might be a little bit difficult, but remember, A negative a is the same thing as a what can I always squeeze in? Yeah, hopefully your answer is I can always squeeze in a 1. So in this case right here, 4 times negative 1a, even though you say to yourself, those aren't like terms, you can't combine them. But that's only with adding and subtracting. With multiplying, I actually can combine them. And what I do is I multiply the 4 times the number out in front, which is 4 times negative 1, which is a negative 4. The a was multiplied with it, so I just actually bring that a alongside. So a 4 times negative 1a is a negative 4a plus 4 times, swoop it out, 4 times 2, which is equal to 8. These aren't like terms, so I cannot combine them together. That's my final answer. Using that information there, if you could for me, please pause the video and I'd like you to try the one on the right side here for me. So hopefully you looked at this and you kind of had the same idea as what we did on the left side there. You have a negative 2 times the quantity that's inside there. So we have a negative 2 times 7m. Remember how I said before, you just take your numbers and multiply them together and then the m kind of just rides along. So negative 2 times 7 would get negative times a positive gives me a negative. 2 times 7 is 14 with the m that rides along with it. Negative 2 times what number is here? Remember, always looking out in front. We have a negative 3. Think back to the beginning of the year. A negative times a negative gives us a positive. 2 times 3 is equal to 6. And this would be your final answer, negative 14m plus 6. Now what we're going to do is we're going to combine all of this together in a couple of problems here real quick. So hopefully you have some success with the video itself. I'm going to ask you to try to simplify 3x plus 2 times 5x minus 7. Taking a look at this, what I'd always do first is if there's any distributing that is involved, we should do that first. And so I'm going to take my swoop and I'm going to multiply my 2 times 5x and my 2 times negative 7. And so that's going to give me a 10x and then minus 14. Notice how that 3x just rides along with it. So this piece of it goes to each spot. Now, if you take a look and you scan across and say, oh, look at this, I have a 3x that's here, and I have a positive 10x there, 3x plus 10x, that would give me 13x. That negative 14 had no like terms with it, so it just rode alongside, and so we would just have that together with 13x and then minus 14. This would be your final answer. These two things are not like terms. We can't combine them together because the 14 doesn't have an x with it. We'll do just one more problem real quick to help you out. Notice how, so that you have some success with it, notice that if I do my distributing first, what number is actually being multiplied out there? It's actually a negative 3. So make sure when you're multiplying that negative 3 to each one of your terms. Okay, so the 9's going to ride alongside, so that's going to slide off to the side there. Let's do negative 3 times positive 2. Think to yourself, negative times a positive, 3 times 2, that would give me a negative 6x, and then a negative 3 times a negative 4. A negative times a negative gives me a positive 12. And so I would have a 9 minus 6x, because it was a negative 6 from up here, plus 12. Looking for my like terms, you hopefully are saying to yourself, any like terms that are up here? Well, there's no x, so that's not any like terms, but there is a 9 and positive 12 that we can combine together to get a positive 21. Remember I said at the beginning real quick that the x's are going to go first, plus 21. What I'd like you to do right now is take this information here, and I'd like you to try the worksheet, which is what happened to Ray Flob after he fell off the Empire State Building. Hopefully you find success with it. If not, come on back to your notes or try to watch the video one more time. Thanks, everybody, and we'll see you next time.